On lab 3, we're going to look at the effects of exercise on muscles and heart rate, and we're going to see how it affects homeostasis in our bodies. Your objective. In this activity, you'll be planning and conducting an investigation to explain how exercise affects heart rate and muscle activity. Introduction. During exercises, your body lets you know how hard you're working, your muscles contract, your breathing increases, and your heart rate changes. In this course activity, you observe the changes in your pulse and muscles during physical activity and relate your results to your body's internal mechanisms that maintain homeostasis. This is your scoring activity, your scoring criteria. This will show you how your activity is scored. In task 1, we'll be looking at measuring pulse, which is important for this activity because your data is going to be collected by your ability to measure your pulse. This will take somewhere between 60 to 90 minutes to complete this whole activity. You will not need much. You can use a stopwatch or on your smartphone, that capability, a piece of paper, and a pen or pencil, however you want to write down your results. Part A, hypothesis and data collection. So to find your pulse, you're going to lightly place your fingertips on either near your carotid artery, which is out by your neck, or the underside of your wrist, as the two images show. You're going to have to probably move around depending on how familiar you are with getting a pulse until you can feel your heart rate. You're going to want to stay still and either be sitting quietly so that you can feel your heart rate. Make sure you use the two fingers that they show in the diagram, not your thumb, because your thumb has its own pulse. And you're going to feel a nice little beat. You're going to want to have your stopwatch, probably your cell phone stopwatch setting handy so that you can click it and then you can just count the beats that you feel within 10 seconds. And the reason why we use 10 seconds is because you can times the number of beats that you count 10 seconds, you can times it by 6, and then you'll find out your pulse rate for a full minute. So question 1. You will measure your pulse during 3 different activities. First, measure your pulse at resting, then while doing 2 activities of your choice. For the best variation, choose moderate intensive activities such as walking, followed by a more strenuous activity such as jogging, or some type of aerobics such as jumping jacks. Choose these activities that you can sustain for 10 minutes. These activities can be performed indoors or outdoors. If you have limited space, you can perform the activities in place, write down your two activity choices. So just in this box, as a sample answer, put walking and jogging. You do not have to pick those 2 activities, but you could. Right here is where you're going to start collecting your data. You'll use the following steps to write down the results on the table. Sit as still as possible for 10 minutes. Then measure your pulse for 10 seconds. Repeat and test 2 more times. So for essentially 30 minutes, you're going to be sitting still, and then after every 10 minutes, you're going to be checking your pulse. For the trials, multiply the measurement by 6 to find the number of beats. So you're going to have your stopwatch, click start counting as soon as you click start. After 10 seconds, you record the number of beats you felt, and then you'll times that number by 6 and get the beats per minute. You're going to take the average of 3 values in the average of resting pulse rate per minute. So right here, what's happened in the sample example, which you do not want to copy, but you can use as a guidelines, is in trial 1, in 10 seconds, the person felt 10 heartbeats. For trial 2, they felt 11 heartbeats during the 10 seconds. For trial 3, they felt 10. So they took 10 times 6 and got 60, 10 times 11 for trial 2, and they got 66 per minute, and then 10 times 6 and they got 60 again. So when they added all 3 of the trials up, divided it by 3, they got an average of 62 beats per minute. So you're going to do the same thing right here in question number 2. So this is where you're going to make some type of hypothesis. How much do you think your pulse will increase during the 2 activities? So if you chose, let's say, walking and jogging, how much do you think your heart rate will increase? Do you think it will increase? You'll reach 75, 100 heartbeats per minute? Do you think you'll be reaching higher than 120 beats per minute when you're jogging? You can do whatever, you can write down whatever you think your heart rate's going to be for the two activities. So for example, I would probably say for walking, my heartbeat would probably increase to probably 80 to 120. If it's jogging, it's going to be 120 to maybe 140, depending on how hard I jog. That would be an acceptable answer. So question number 4, you're going to perform the two activities during a 10 minutes each and record your data in the table. Start with the moderate activity, record your pulse for 10 seconds at 2 minutes intervals. Ideally, continue this activity while you measure your pulse. If it isn't possible to stop and record your data, then quickly resume. If it isn't possible, stop and record your data, then quickly resume the activity. After you complete your first activity, rest until your pulse rate returns to normal. Then try your second activity, repeat the process. So for 10 minutes, they're going to have you doing, let's say, walking. And then when you're 2 minutes into your walking, you're going to record your heartbeats, how many heartbeats you had per 10 seconds. Then at 4 minutes, you're going to record how many heartbeats you had that you had in 10 seconds. And then 6 minutes in, you're going to record how many heartbeats you had in 10 seconds. And then on 8 minutes into it, you'll do the same in 10 minutes. So looking at the example answers right here. So 2 minutes into walking, when they counted their heart rates for 10 seconds, they got 11 beats. Then 4 minutes into it, when they count their heartbeats for 10 seconds, they got 11. 6 minutes into it, they counted 12 beats for 10 seconds, and so forth. Now right here, you got to look at, this is just the heart rate for 10 seconds. So you would just put that for your answers, all they're wanting you. You don't have to times the number by 6 yet. So you'll do your second activity, you'll do the same thing. Now down right here, you're going to be recording your data. So you have pulse beats per minute. So at this point, you're going to have to time whatever times your 11 heartbeats in 2 minutes. You have to times it by 6 to get your correct beats per minute. So in that case, it would be 66 at the end. 3 times 6 is 18. 6 times 1 is 6. Carry that. So you have 78 beats per minute. So they've increased their heart rate. You're going to do the same thing right here. You'll see how right here it's basically showing that in walking, they only got 78 beats per minute. And right here, it's a little bit over 100 beats per minute when they were jogging. So you're going to do the same thing with your activities. Depending on what activities you are, it's going to vary. Compare your two activities that you graph. Did your prediction match your results? So this is either just explain, yes, your prediction did match it, or no, your prediction didn't match it, and why. Now, right here, we're trying to figure out what is your independent and dependent variables in this experiment. So your independent variable is the activities you chose to do, walking or running. Now the dependent variable is your pulse rate. So just go ahead and write that down on question number 3. Why do you think the change in pulse rate help your body maintain homeostasis? So right here, you can read the sample answer, but I want you just to really think about, as you run, what does your body need to keep the muscles moving? It's going to have to create energy. How does it create energy? Well, it creates energy by burning glucose or a source of fuel from oxygen. And so the more work you're doing, the more oxygen it's going to need. So what's that going to increase? And why is your heart rate going to increase? What are you trying to get more to your muscles? You can definitely read the sample answer and then add to it, elaborate, explain what you think, how your body has to maintain homeostasis. If you were running really hard and your body was not increasing the heart rate and you weren't breathing harder, what would happen to your muscles? Would they collapse? Would they cramp? What would happen? So that's the first part, and there's actually 3 parts to this experiment. Second one, you're going to be testing muscle fatigue. So ATP, which is the form of energy that obtains through cellular respiration in the presence of oxygen. So as you breathe in, your muscles get energy through ATP. During intense activities such as exercising, oxygen decreases the muscles performed by anaerobic respiration, which is fermentation of lactose acid. So basically it's creating energy a different way without oxygen. This process leads to muscle fatigue. In activity, you'll measure the rate at which the muscle fatigue sends into your hands due to repeat activities. So right here, you're going to read the background, what you're going to need, either a tennis ball or you're going to need a crunchy nut paper to squeeze for your hand. Again, you have a stopwatch, which you can use your cell phone, a pen, and paper to write down your results. So right here, I'm not going to go through every single one, but read the direction for the hypothesis and data collection. And you can use a sample answer again so that you could formulate it if you want to. Make sure you do not copy it word for word. It has places where you record your data for squeezing. You're going to graph it. Based on your graph, you're going to say, does your predictions match it or not? You're going to talk about when did your muscles start feeling the lactic acid fermentation? How did you know? So lactic acid shortly is what builds up in your muscles as you're creating ATP without oxygen. And typically it's a type of soreness, and that's why if your heart rate's not increasing enough or you're not getting enough oxygen to your body, it's going to start creating lactic acid in your muscles. That's why after you work out a hard workout, the next day you're extremely sore because the built up in your muscles of lactic acid that needs to be flushed out by time and by drinking fluids. So just read the questions and answer them the best you can. Make sure I'm looking at the effort you're putting into it, as much detail as possible, and that's how I'd be basing your grade on. The third part of this activity is where you're going to create your own experiment based on the results in the, excuse me, let me go back all the way up. So you're going to design your own experiment to test how your body changes during exercise. You kind of did this in the first time, and so you can use it similarly and just write down. Right here, we're trying to really see how you can create your own experiment and how you understand the scientific method. So you're going to formulate a question, and keep in mind you should be able to answer the question and measure it. Write your question here. So it could be as simple as, when I'm running, my heartbeat will increase up to 140 beats per minute. And that's really specific. Or the faster I run, the harder my heart will beat, which will increase my breathing and heart rate. So right here they put, how does the heart rate change during a cool down portion of a 30-minute workout? So right here, you're going to write down your plan for your experiment, your independent variable, and to ensure the results test only the dependent variable, consider how you will control the outside factors. So for the sample right here, the dependent variable will be my pulse. The independent variable will be the length of time and the amount of exercise. I intend to take a brisk walk 30 minutes, followed by a very slow walk for 5 minutes to cool down. I'll record my pulse for 10 seconds at the end of the brisk walk and at the intervals of 1 minute afterwards for the 5-minute cool down walk. For accuracy, I will ask my friend to hold a stopwatch and record the data. You may not have a friend, so you're going to have to explain how you're going to test your dependent variable and what you're going to do. The main thing is we're trying to see the reflection on how to eliminate or control most of the other factors. So you'll write down your prediction, you'll carry out your experiment, you will graph your experiment, you will talk about your conclusion based on your results, and then you'll be finished. If you have questions on this or you get confused, please feel free to give me a call. Have a good day.